Okay, here we are on day 39 and in our lesson. Now this lesson is, we're also going to divide into two parts. So we're going to start on the first part. Going to our math windows on page 5 of 12. And here we go. Expand the expression below. And that's a polynomial times a polynomial. Is there polynomials? I forget if they're called polynomials. Okay. So this first part has two terms. It has a 3x and 2y, an x term and a y term. And it's multiplied times this part over here, which also has two terms, 5x and minus 6y. So when you multiply, we've done this before. When you multiply, you have to multiply the first term times the first one over here, and then the first term times the second term over here. Then you also have to multiply this term times the first one and this term times the second one. So there's four multiplications. 3x times 5x. 3 times 5, you can change them around, so you can multiply the 3 times the 5 is 15. And then you have an x times an x, which is x squared. Now the 3x times minus 6y, a positive times a negative is negative, minus 18, and we're going to keep the x first and the y second alphabetically. We could put yx, but we're going to do xy. Okay, 2y times 5x. So 2 times 5 is 10, when it's positive, plus 10, and it's yx, or you could put xy. We'll keep it xy because that's what we did on the other one. And finally, 2y times minus 6y. 2 times 6 is 12 minus 12, and you have a y times a y. That's a y squared. Now, you could leave it at that, but this is x squared, this is y squared, but these are both xy, so we can combine them. 15x squared. You have minus 18 plus 10. It's like 10 minus 18. That would be minus 8. When one's positive and one's negative, you subtract the 10 from the 18, and you take the sign of the bigger one. The sign of the bigger one is 18, so we get minus 8xy minus 12y squared. And that's it. Okay. Again, please try these before you look at the answer and see if you get the same as me. Okay, what is the value of the expression below? Well, they're testing you to see if you know what you do first before you do the other operations, order of operations. Are you going to multiply 2 times 4 first? No, you have to subtract this first before you. Typically, if it says 2 times 4, you do the multiplication first. But since this is in parentheses, that's going to be done first before you multiply. Okay, 3 times 5 squared. Well, you don't go 3 times 5, 15. Squared comes first. Exponents come first. So 5 squared is 25. 5 times 5 times 3, 75. Plus, what's all this going to be? Well, 4 minus 18 we do first. 4 minus 18 is the opposite of 18 minus 4. 18 minus 4 is 14. 4 minus 18 is negative 14. Times 2, negative 28. We could leave it like this, 75 plus negative 28, or we could just get rid of the plus. 75 minus 28 plus 3 to the third. This means 3 times 3 times 3. You multiply 3 times itself 3 times. 3, well, I'll write this up here in case you don't understand what I'm saying. 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So 75 minus 28 plus 27. You know, if I'm going to subtract 28 and then add 27, I'm just going to subtract 1. Because first you subtract 28 and then you add 27 back. It's the same as subtracting 1. 75 minus 1 is 74. Of course, if you want to use your calculator, you can do that too. 74, that's what I got. Did you get that? I hope I'm right unless I made a mistake. Okay. So I'm going to go down here. One number is 12 more than 3 times another number. The sum of the two numbers is minus 20. What are the numbers? Now I could figure this out using x. I'll do that second. Suppose I try doing it just by trying the answers. So one number is 12 more than 3 times the other number. So one of these numbers is 12 more than 3 times the other number. So I'm going to have to take the bigger one, but the bigger one's not even 12 more than 8. So if you multiply 3, it's going to be 12 less than 3. So that one can't be, the numbers can't be that close together. They have to be far apart because it's 12 more than 3 times the other number. Okay. How about 8 and negative 12? Well, this is the small one. If I multiply it by 3, it's just going to become more negative 36. They'll be way apart. That's not going to work. How about if I multiply this? No, then they're going to be way apart again. So we can't use those numbers. How about this one? 3 times the other number. I don't want to multiply 3 times that. It'll get way smaller. If I go 3 times that, it's negative 6. Is negative 6 12 more than that? Yeah, negative 6 is 12 more. That one looks like it's going to work. Watch again. If I do this number, this number is 12 more. No, this number is 12 more than 3 times the other number. No, this number is 12 more than 3 times itself. Oh, no, that doesn't make sense. So that C doesn't look like it works after all. How about this one? This number is 12 more than 3 times the other number. 3 times minus 28 is minus 24. Minus 12 is 12 more. This one looks like it works. Okay, you could just try them out. Okay, let's say I wanted to do it the mathematical way. Okay, one number is 12 more than 3 times the other number. So we're going to say the other number is x. That's the other number. So 3 times x plus 12 is equal to one number. And the sum of the two numbers is negative 20. I got to remember that too. Okay, I forgot to do that. Are these all negative? These two aren't even negative 20. So forget those two. It's got to be one of these. Okay, is equal to, is one number, is the other number. And the other number, the first number we're calling x. And when you add them together, x plus 3x plus 12 is equal to minus 20. You add it together, minus 20. You get 4x plus 12 equals minus 20. Subtract 12 from both sides, you get 4x equals minus 32. Divide by 4, x equals minus 8. So one number is minus 8. The other number is 3 times minus 8 is minus 24 plus 12 is minus 12. Minus 8 and minus 12 are the two numbers. And there it is, D. To me, it was easier just to try the numbers and find two that work. I didn't really pay much attention to this first one. The sum of the numbers is minus 20. That's 20. That's minus 4. These two are out because they don't even add up to minus 20. It's got to be one of these. They both add up to minus 20. And you want to multiply 3 times one of them. 3 times this is minus 6. But then this one would be 12 more than that. And it's got to be 3 times this is 24, minus 24. This number is 12 more than 3 times this. That's what you want, so D works. Okay. If the area of a circle is 36 pi, what is its diameter? Well, the rule for the area of a circle is pi r squared, where r is the radius. Now the radius is this part from the middle to the out, right? The diameter is when you go all the way through. The diameter is the whole thing. It's 2 radiuses, right? So if this is the equation for the area, pi r squared, and this is the area, pi times 36, we know that r squared is 36. What times itself is 36? 6 times 6. So the radius must be 6. If the radius is 6, the diameter is all the way across would be 2 times that, 12. There we go. Okay, on to our lesson. Okay, we're moving off of some of that algebra we've been doing. This is something old here. Let's get rid of that. We're moving away from the algebra and we're moving towards studying some geometry and geometrical shapes. And we're doing plane figures first. And in this lesson day 39, we're going to be working with four-sided plane figures. Okay, so what we're going to be doing, dividing this into 2 days work, we're going to work with learning the different four-sided figures there are, and learning about the angles that four-sided figures have. The angles are the parts on the inside of the corners of a four-sided figure. Okay, the second part of our lesson, 39b, we're going to be learning about how to find the perimeter and how to find the area of these four-sided shapes. Okay, but for now we're just talking about the kinds of four-sided lines, and they have this graph here that shows you some of the kinds here. Let's make it a little bit bigger. Okay, so if you got all four-sided shapes are called quadrilaterals. Quadra sounds like quattro, four sides, okay? All shapes have four sides. They can be the same, they can be different, they can be parallel, they cannot be parallel, it doesn't matter. Now, if we take a four-sided shape and we have two sides parallel, just two opposite sides parallel, the other side's not parallel, that's called a trapezoid. And a trapezoid, as you can see here, has a parallel side that corresponds to the one on the bottom. And they can't be equal either. If they were equal, then we're getting into like rectangles or parallelograms. Anyway, that's a trapezoid. Okay, we're going to skip kite for now. Now, a trapezoid has parallel sides, has one parallel side, right? Now, I guess a trapezoid with two parallel sides, two pairs of parallel sides, where the top is parallel and the sides are parallel, is called a parallelogram. Okay? If you follow that further and you make all the sides the same, now we have a rhombus. Parallel, parallel, and equal. That's a rhombus. Over here, this trapezoid, the sides are the same. These sides that are not parallel are the same. Now, in a trapezoid, you have unequal sides here, right? These, when they're the same, it's called an isosceles trapezoid. They don't talk about that much. If you've ever worked though with those little pieces in elementary school, what are they called now? I can't remember the name. Anyway, they have different colors. The trapezoid piece is an isosceles trapezoid, and it's red. The parallelogram piece, which looks like a diamond, is blue. Okay, you might know what I'm talking about. Those little colored things that we play with in school. Okay, if you have a four-sided figure where it's a parallelogram because you have two pairs of parallel sides, plus you're using right angles, then it's a rectangle. And if all the sides are the same, then it becomes a square. A rhombus is related to a square because all the sides are the same. But in a square, you have right angles. So a square is a rhombus with right angles. A square is a rectangle with all sides the same. It's as though if you married a rhombus with a rectangle, you would get a square for a child. Both all sides the same and four right angles. Anyway, the one I skipped was kite. In a kite, you have two pairs of equal sides, like a parallelogram, except that the sides correspond to each other. They're touching adjacent each other, whereas here they're opposite. The sides are opposite. They're also showing you here in a parallelogram, this angle is equal to this angle. The opposite angles are equal. in a parallelogram. In the rectangle and the square, the angles are all the same. They're right angles, they're called. Now, all of these add up to, if you measure the angles, they all add up to 360 degrees. So if this is 110 in a parallelogram, that one's 110. Together, they're 220. Since a four-sided figure has 360 degrees, you could subtract the 220 from the 360 and get 140, and then one of the angles would be half of that. Half of 140 would be 70. So that angle is 70. So you can figure out the angles in certain shapes if you know the rules for those shapes. And you remember that all four-sided figures have 360 degrees. Anyway, read through this page. It'll do a lot of explaining in a much clearer manner than I just did. And it'll help you in solving problems. Okay, so we're going to jump to some exercises. I'm skipping over the part that talks about the area and the perimeter. Okay, we will do that in the second lesson. So right now, I'm going to go to page 8 of 12 and answer some of these questions. Okay. List the names of the four-sided figures that exhibit the following properties. Write none if no four-sided figure has this given property. Four right angles. Well, you know that. Which ones have four right angles? You can refer back to the other page, the graph of the shapes, if you want. So which ones with four right angles? Of course, the rectangle and the rectangle and the square. Remember, the square is a special rectangle. Square is a rectangle also, just a special one with four equal sides. Opposite sides are equal in length. I'm having trouble finding my first page here. Is that it? No. Here we go. Opposite sides are equal in length. That would be a parallelogram, right? This one's equal to this one. This one's equal to this one. Isosceles trapezoid, no, because these two are different. No. Rectangle also works. Opposite, equal length. Square works. And rhombus works. So all four of these work. So you could put all of them. Parallelogram. Whatever. Rectangle. Square. And rhombus. Rhombus has that H in there, doesn't it? Somewhere. Rhombus. Exactly one pair of parallel sides. Which one was the one that only had one pair of parallel sides? That was the trapezoid, right? One pair of parallel sides. Trapezoid. Trapezoid. All angles are equal in measure. All angles are equal in measure. If they all add up to 360 and they're equal in measure, they have to be 90 degrees. Which ones had 90 degrees? The rectangle and the square, right angles. If they're all equal in measure, they have to be rectangle and square. Only three right angles. Okay, let's see that. You got a right angle here, a right angle there, and a right angle there. Three right angles. Oops, what's going to happen? That fourth one has to be right, because if there are three right angles, that's 270. What's left is 90. That's going to have to be right too. There are no shapes that only have three. None. If they have three, then they have to have four. Opposite angles are equal in measure. Opposite or equal. Again, that's the parallelogram. And all its children, the opposite or equal. So the same as this one. Parallelogram, rectangle, square, I'm really abbreviating rhombus. All four sides are equal in length. Do you remember which ones they were? Well, the square for sure. But what was the other one? The square is a special what? Not rectangle. They don't have to be equal. Rhombus. The rhombus. And rhombuses can be squished. They can be really thin. They can be like a square, or they can be like a diamond, right? Or they could be a really thin diamond. Like that. Okay. Sum of interior angles is 360. All of them. If it's a four-sided figure, it adds up to 360. All of them. I'm going to write them out. All of them. Sides are of different lengths. All the sides are of different lengths. Well, if all the sides are different lengths, can it be a trapezoid? A trapezoid can have all the different lengths, but it doesn't have to. If they must be different lengths, then I think there's a name for that. There's a special name for it. Quadrilateral is all of them are quadrilaterals, so quadrilateral doesn't apply. There is a special name for a shape that has all different lengths, but I don't think they put it down here. I'll have to look that one up. It could be a trapezoid, though. It cannot be a square, cannot be a rectangle, cannot be a rhombus. It cannot be a parallelogram. It could be a trapezoid. It could be a trapezoid, and it could be, of course, the quadrilateral. Okay, 4 equal angles and 4 equal sides. 4 equal angles and 4 equal sides. 4 equal sides could be a rhombus and a square, but a rhombus doesn't have to have 4 equal angles. Only the square has 4 equal angles. They're all 90 square. Okay, moving on. List all figures from those shown below that meet the conditions of each quadrilateral. So, what we want to do is look for the ones that are parallelograms. Is that a parallelogram? Yes, it's a special one. A, B, C. What does it say? That condition of each quadrilateral. A parallel? No, that's not parallelogram because it has two sides. Not. D is a square is on its side, but it's still a square. E, no. F, yes. G, yes. H, no. I don't know. Is that tilted? I guess that is. Let me see. No, I is a little bent. So I'll say, well, it's a parallelogram. That's still good. It's just bent a little. That's okay. I, J, no. Where's K? J, L. What happened to K? Well, anyway. L, no. Tampoco. 2, rectangle. A is a rectangle. B is a rectangle. How about D? Is that a rectangle? It's a square, but a square is a rectangle, so that one counts. G looks like a rectangle. No more. Okay, rhombus. Rhombus, all 4 sides the same. D is a special rhombus called a square. Any other one? No, not quite. No. They should have put a bent over rhombus, like a diamond, but they didn't put that there, so we only got D. Square, just D. Right, there weren't any other squares, okay. This says isosceles triangle. I think they meant the isosceles triangle isn't even 4-sided. It says 4-sided quadrilateral, so this should say trapezoid, right? Trapezoid. So I'm going to pick this one. It's isosceles, pretty close to isosceles. This side is kind of like that side. I don't know if it is perfect. Same with J. This side's the same as that side. So I'm going to say C and J. C and J. Now trapezoid, we already know C and J are good. Is there another trapezoid there? How about H? Well, you know, H, no, H, they're definitely not the same, but it is a trapezoid, just not an isosceles trapezoid. Okay. You might have seen some more answers. If so, you can check in the back and see if there's any more. Okay, so we have one more page I'm hurrying to because I know my battery's going to go. Okay. More questions. This involves the angles. Okay, so here we go. Questions 11 and 12 refer to the following figure, okay? What kind of figure is it, first of all? Well, it's got one pair of parallel sides. That's a trapezoid, even though it's not an isosceles one. Isosceles one would look like that. Angle F is 20 more than 3 times the measure of angle H. What is the measure of angle F? So angle F is bigger than H. So what's the big one? Is it 40? Well, if this is 40 and it's 20 more than 3 times that one, that would mean if this is 20 more than this, it's 3 times more than 20 is 3 times more than that. That would make that about 7 and something. That's too small. How much do these add up to, first of all? Well, this is 90, this is 90. That's 180. How many in the whole thing? 360. So if you subtract, you get 180. These two add up to 180. And one of them's big and one of them's small. 40 is way too small. How about 120? If this is 120 and it's 20 more than 3 times that one. If this is 120, right? Then the other one, they add up to 180, so the other one must be 60. 3 times 60 is 180 plus 20 is 200. That doesn't work. Let's try this one. 140. 140. Okay, if this one's 140, the other one must be 180 minus 140 must be 40. Is this one 20 more than 3 times that? 3 times that is 120 plus 20 is 140. This one works. You know it couldn't be 180 because together they're 180. That one would be 0. So it has to be C. Now you could have done it algebraically. If you call this one X, you say X plus 3X plus 20. This is the small one. This is 20 more than 3 times the small one. Together they equal 180 because we figured out these two have to be 180 because these are 180. You get 3x, you get 4x, and you subtract 20 from both sides, it's 160. Divide by 4, you get 40. So this one's 40, and this one's 20 more than 3 times 40, 140. Okay. It was easier, again, just trying the angles and seeing which ones worked. Okay. In order for figure EFGH to be a trapezoid, which of the following must be a true statement? EF is the same length as FH. EF is the same as FH. Must they be the same? No, that's not the definition of a trapezoid. How about EF is parallel? That means parallel to GH. This one's parallel to this one. Yeah, they got to be parallel for it to be a trapezoid. You need one set of parallel. That one's true. The angle F is equal to angle H. This angle is equal to that angle? No, they're not equal. One's bigger. Angle G is equal to angle F. Angle G is equal. Opposite one's equal? No, this is 90. That's not equal. So it was B. Moving on. Now, you got a square, right? If the opposite sides in RSUT are parallel, what is the measure of angle R? Well, they all say 5, so it's a square. All the angles have to be the same. If these two are 90, then these two must also be 90. 90 degrees. 4 90s is 360. Last one. A four-sided figure has sides measuring 10, 15, 10, 15. The opposite angles are equal, but there are no right angles. What is the figure? So it's 10, 15, but not a right angle. 10, 15. So these two are equal and these two are equal, but no right angle. What shape is that? Well, it's not a rectangle because there's no right angle. It's a parallelogram. Two pairs of parallel sides. C, parallelogram. Is it a rhombus? No. Rhombus, they'd all have to be the same. They're not the same. A rectangle? Nope, no right angles. A trapezoid? No, because it has two pairs of parallel sides. That makes it into a parallelogram. Okay.